Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having a good time. So people, you can first of all let me know in the chats if I'm audible and visible to everyone, right? Good evening Ishpreet, hello Ashwarya, hi Arox, hi Chitra, hi Dakshin, hello Arva. Welcome back, hello Afshan, hi Narmada, hi Noreen. Welcome back. Hello, Monisha. Hello, Sharanya. Welcome back, everyone. Welcome back. Just let me know, give me some green signal from the chat box so that I'll get to know that I'm audible and visible to you. Yeah. Hello, Nandini. Welcome back. Hello, Chitra. Welcome back. Welcome back, everyone. Welcome back. All right, people. So as you all must be knowing, we are done with the chapter Redox Reactions, right? And in the tonight's session, what we are going to do is we are going to solve all the questions, all the previous year asked questions from your JEE examination from the chapter Redox Reactions. Whatever questions have been asked till now from the chapter Redox Reactions, all those questions will be done in the tonight's session, right? And I'm sure you guys are going to kill these questions properly, right? Because we have talked about all the concepts which are involved in the questions which have been asked from this chapter, right? Hello Riyaz, hi Shashank. Welcome back everyone, welcome back. So before starting the session, the ones who are new to the channel, let me introduce myself first. Well, my name is Wassim Sir and I'm your chemistry master teacher writer on this JEE Enthuse channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel, right? So please do like the video, share the video with your friends and do subscribe to the channel as well, okay? All right guys, hello Ishwar, welcome back. All right, so people, you can let me know in the chats if you guys are super duper excited about this session as well. Let me know fast in the chats. Sumant, Redox Reaction chapter is going to get completed tonight. Tomorrow we are going to start chemical equilibrium. And the ones who are waiting for chemical bonding I started today on NEET Lead channel. So you can parallelly go for two chapters. Chemical bonding on NEET Lead channel and chemical equilibrium on this JEE Enthuse channel, right? Hello Shashank, welcome bro, welcome. Okay, so then let's get going. Let's get started with the previous year questions from the chapter Redox Reactions, right? Well people, the first question which was asked in JEE 2021 March, JEE Mains 2021 March attempt, this question was asked, right? We were given the reaction 2 times MnO4 negative plus B times oxalate ion plus C times H positive gives X times Mn di positive plus Y times carbon dioxide plus Z times water. If the given equation is balanced, the value of C will be. I need to get the value of C, right? Yes. Munish will be doing the GOC after chemical bonding. Once chemical bonding is over on NEET Lead channel, after that I'll be starting GOC, right? Yes. See guys, how this sort of equation I'm going to solve. First of all, what are we going to do exactly? We are going to balance this reaction, that's all, right? And balancing the reaction in acidic medium can be done either by ion electron method or you can use the oxidation number method. The choice is all yours, right? See, the reaction actually is like this. MnO4 negative, it converts oxalate ion. It converts oxalate ion in acidic medium into what? Into carbon dioxide, and itself gets converted into Mn di positive, right? This is something which I have discussed in the normal sessions, right? MnO4 negative or KMnO4, it converts oxalate ion in acidic medium into carbon dioxide, and with this, your MnO4 negative gets converted into Mn di positive, right? Shashank, the second channel is NEET Elite channel, okay? NEET Elite. Right? All right, so let's try to balance this equation first. I'll be using the oxidation number method to balance this reaction. Let's see how it's to be solved. Understand? Well, the oxidation state of manganese over here is +7. The oxidation state of carbon right here is +3. When you calculate it, 2x minus 8 is equal to -2. So the x value will come out to be +3. Oxidation state of carbon is +4 and the oxidation state of manganese is +2, right? Now we will have a look. What is the change in the oxidation state of carbon? From +3 to +4. change in the oxidation state of for carbon. It's going to be final oxidation state of carbon minus initial. Value comes out to be 1. 1 is the change in the oxidation state for one atom of carbon, but I have two atoms, so I'll say N factor of this oxalate ion over here is going to be 2. Similarly, the oxidation state of manganese is changing from +7 to +2. So what is the change in the oxidation state of manganese? Final oxidation state of manganese minus initial. The value comes out to be what? Value comes out to be 5. So 5 is the N factor of MnO4 negative in acidic medium, right? Now once we get the N factors, I'm going to take this N factor of oxalate and keep it as the stoichiometric coefficient of MnO4 negative. Similarly, N factor of MnO4 negative, right, that is 5. This I'm going to keep as the stoichiometric coefficient of oxalate ion, right? So this is something which we have done till now, right? After this, let's try to erase all these oxidation states. Now, after crisscrossing these N factors, what is the next step? The next step is going to balance all the atoms except hydrogen and oxygen. We have got 2 manganese on this side, so this should be 2 times. We have got 5 to the 10 carbons on this side, so this should be 10 times. We have balanced all the atoms except hydrogen and oxygen, right? Now, in acidic medium, we are going to balance the oxygen first. And how do we balance oxygen? By adding water molecules, right? Have a look exactly. How many oxygens are there on the left hand side? 4 2s are 8, 5 4s are 20. So total 28 oxygen atoms are there on left hand side. And on the right hand side, 10 2s are 20, there are 20 oxygen atoms. If I ask you, which side is oxygen deficient? You'll clearly say right hand side is oxygen deficient, right? So you need to add some 8 water molecules on this side, then only oxygen gets balanced. Check it out now. Oxygen got balanced, right? By adding 8 water molecules. 28 on this side, 20 on the right hand side as well. Now after balancing the oxygen atoms, it's time to balance the hydrogen atoms. And how do we balance the hydrogen atoms in acidic medium? By adding the H positive ions. How many H positive ions do we have here? 8 2s are 16. So on this side, I'm going to add 16 H positive ions. This reaction is a balanced chemical equation. Now, what was I supposed to calculate? The value of C. C is the stoichiometric coefficient of H positive. C is the stoichiometric coefficient of H positive. The value of C comes out to be 16. So 16 is going to be the answer of the equation, right? Let me know in the chat if it is clear to everyone so that I can move on to the next one, right? Absolutely, guys. 16 is going to be the answer of this question. Yeah? Okay, let's move on to one more question. The question was asked in your mains 2021 March attempt, right? Okay, one more question from JEE 2021 March. This year's JEE examination, one more question was asked from the same chapter. See guys, what the question was. It was mentioned that 15 ml of an aqueous solution of Fe dye positive in acidic medium completely reacted with 20 ml of 0.03 molar aqueous Cr2O7 dye negative. The molarity of Fe dye positive solution is dash into 10 raised by -2. What is going to be this term in the dash? Correct? That's something I need to calculate. The question is from redox titration, right? Well, people, if you remember, in acidic medium, Cr2O7 dye negative, in acidic medium, it converts Fe dye positive into Fe tri positive, right? And itself, the Cr2O7 dye negative gets converted into Cr tri positive, right? Okay. So first of all, let me calculate the N factor of this Cr2O7 dye negative. Have a look on the oxidation state of chromium. Right here it's +6. Right here is going to be +3. So +6 to +3, what is the change? Change in the oxidation state of chromium is going to be final oxidation state of chromium minus initial. The value comes out to be 3. 3 is the change in the oxidation state for one atom of chromium, but I have 2 atoms, so 3 2s are 6, right? So N factor of this Cr2O7, which I'm representing by number 1, right? Let me represent this by number 2. So N factor of Cr2O7 came out to be 6, right? What about the N factor of Fe dye positive? +2 to +3, what is the change? 1 is the change in the oxidation state for one atom of iron. So its N factor is going to be 1, right? I got the N factor of both, correct? I got the N factor of both. I got the N factor of Cr2O7 dye negative. I got the N factor of Fe dye positive as well. Now we will have a look exactly. 15 ml of aqueous solution of Fe dye positive. I'm given with the volume of Fe dye positive as well, which I represent by V2. It's given to me as 15 ml, right? Completely reacted with 20 ml of 0.03 molar aqueous. Okay, volume of Cr2O7 dinegative, it's given to me as 20 ml. At the same time, molarity of Cr2O7 dinegative, it's given to me as 0.03, right? What do I need to calculate? The molarity of Fe dye positive solution. I need to get the value of M2, right? What is the concept which I'll be using? The concept which I'll be using, I'll be just equating the milliequivalence of first with the milliequivalence of second as per the equivalent concept is concerned. Milliequivalence of first reacted should be equal to milliequivalence of second reacted. And how do I write the milliequivalence of first? It's going to be normality of first multiplied by volume of first in ml should be equal to milliequivalence of second, normality of second multiplied by volume of second in ml, right? Now people, normality of first will be simply equal to molarity of first multiplied by n factor of first. Molarity of first is 0.03, n factor of first is 6, the value comes out to be 0.18. I got the normality of first, right? Okay, let's assume the normality of second I'm representing by n2, right? So people, have a look. N1 value I got to know as 0.18, V1 value was given to me as 20 is equal to N2 value I need to calculate, and V2 value is coming out to be 15, right? 15 ml. So from here, can I calculate the normality of the Fe dye positive solution? Absolutely. Yes. And normality of Fe dye positive solution, how much it comes out to be? Can you let me know in the chats? Can you let me know in the chats after solving this, what is the normality value, N2 value coming out to be? I'm waiting for your answers. Let me know fast in the chat box. What is the N2 value which comes out to be after solving this? Well, people are saying it is 0.24. But people, was I supposed to calculate the normality of second or molarity of second? I was supposed to calculate the molarity of Fe dye positive. I calculate the normality, right? So normality of second is going to be equal to molarity of second multiplied by n factor of second. It is equal to 0.24, right? N factor of second is going to be equal to 1. This term is 1. So molarity of second is 0.24. 0.24 I can write as 24 in 10 raised power minus 2. So this thing is equal to 24, which I was supposed to calculate, right? Yes, I'm sure it's clear to everyone. Simple, Harini, if you have seen the earlier sessions of redox, right? I've taught the redox titration, and in the redox titration, we just equate either the gram equivalence or the milli equivalence and get the desired answer, right? That's what I did over here. If you have not seen the redox titration topic, I would suggest you to go through it once, then only you can solve these questions. Otherwise, you won't be able to solve, okay? Perfect. Moving on to one more then. JEE 2021 February attempt. Okay, this year question it is again. In mildly alkaline medium, thiosulfate ion is oxidized by MnO4 negative to A. Alright, the oxidation state of sulfur in A is, let me tell you, MnO4 negative. Let me tell you, MnO4 negative in alkaline medium, it converts thiosulfate ion into sulfate ion, right? Do remember this. MnO4 negative in alkaline medium, right? It converts thiosulfate ion into the sulfate ion, SO4 dinegative, right? So this A is basically going to be SO4 dinegative. And in case of SO4 dinegative, what is the oxidation state of this sulfur? Let's assume it as X. Oxygen shows -2 oxygen state, 4 oxygen atoms, net charge -2. The value of X comes out to be +6. So +6 is going to be answer of this question. As simple as that, right? Yes? People, is it simple? Absolutely. Remember, MnO4 negative converts thiosulfate ion into what? Into the sulfate, SO4 dinegative, in which the oxidation state of sulfur is simply going to be +6. As simple as that, right? Yes? Right, people? So your thiosulfate ion, S2O3 dinegative, in presence of MnO4 negative in alkaline medium gets converted into SO4 dinegative. And in SO4 dinegative, the oxidation state of sulfur is simply going to be +6. The question was asked in JEE February 2021, right? Okay. One more question, guys. The question was asked in JEE 2021 February attempt. JEE Mains February attempt 2021, right? The same type of question. See, guys, how this sort of a question is to be solved. Again, a very simple and basic one. Have a look. The volume in ml of 0.02 molar K2Cr2O7. So I'm given with K2Cr2O7, right? Required to react with 0.288 grams of ferrous oxalate. This is ferrous oxalate, right? In acidic medium is If you remember, we have discussed K2Cr2O7, it converts Fe di-positive into Fe tri-positive, it converts oxalate into carbon dioxide. I'm not going into the details. I hope you remember the N factors of K2Cr2O7 and ferrous oxalate in acidic medium. First of all, let me represent this by number 1, let me represent this by number 2, right? N factor of K2Cr2O7 in acidic medium is going to be 6, N factor of ferrous oxalate is going to be 3, right? Okay, this is something which we have discussed in detail when I taught you the N factors in this chapter only, right? The volume in ml, I need to calculate the value of V1, right? Molarity of K2Cr2O7 solution is given to me, M1 is given to me as 0.02, right? Okay, required to react with 0.288 grams, right? So mass of this ferrous oxalate, it's given to me as 0.288 grams, correct? What do I need to calculate? I need to get the value of V1, right? Now guys, how do I solve this? How do I solve this? First of all, again I'm going to equate the milliequivalence of these two. I'll say milliequivalence of K2Cr2O7 reacted in the reaction must be equal to the milliequivalence of ferrous oxalate, right? So milliequivalence of K2Cr2O7, I can write it as normality of K2Cr2O7 multiplied by volume of K2Cr2O7 in milliliters is equal to, right? Milliequivalence of ferrous oxalate, I can write mass of ferrous oxalate divided by equivalent mass of ferrous oxalate multiplied by 1000. There is one more relation, mass of substance divided by equivalent mass of substance multiplied by 1000, by means of which you can write the milliequivalence of the substance, right? Yes. Now we will have a look exactly. Have a look exactly. N1 value, N1. N1 is normality of what? K2Cr2O7, which is equal to molarity of first multiplied by N factor of first, right? Molarity of first is 0.02, N factor of first is 6, the value comes out to be 0.12. N1 value is 0.12, correct? V1 I need to calculate is equal to mass of ferrous oxalate in grams, that's given to me as 0.288 grams divided by equivalent mass of ferrous oxalate. Equivalent mass of ferrous oxalate is going to be molar mass of ferrous oxalate divided by N factor of ferrous oxalate. Well, N factor of ferrous oxalate we know. Can you let me know what is the molar mass of ferrous oxalate in the chat? Someone of you? Any one of you? What is the molar mass of ferrous oxalate? Fast. Calculate it, let me know. Calculate it and let me know what is the molar mass of ferrous oxalate, FeC2O4. I'm waiting for your answers. Till then I can have some water. Let me know what is the molar mass of ferrous oxalate, guys. Okay, Riaz is saying the molar mass of ferrous oxalate is 134. All right, I trust you. So equivalent mass of ferrous oxalate means molar mass of ferrous oxalate divided by N factor of ferrous oxalate, which is 3, right? Multiplied by 1000. Correct? So people, you just got one equation in which you have got only one variable, that is V1, and V1 is the volume of K2Cr2O7 which I was supposed to calculate, right? Yes? Okay, 144 it is, alright, it is 144, fine. Now it's correct, yeah? Okay, so people, now it's going to be your turn after this because you got one equation in which there is only one variable. What is the variable? V1. V1 you are supposed to calculate, that's all. Yeah? Right people? So finally, you get the V1 value by calculation as 50 ml. That is going to be the final answer of the question, right? I'm sure it's clear to everyone. Well, JEE 2019 mains, right? The question was asked in JEE mains 2019. The compound that cannot act both as oxidizing and reducing agent. Which compound cannot act both as oxidizing and reducing agent? Well, if I look at the options, see, if I look at the options, if you look at this H3PO4, what is the structure of H3PO4 first of all? This is P double bond O, oxygen attached with hydrogen, oxygen attached with hydrogen, oxygen attached with hydrogen. If I ask you, what is the oxidation state of phosphorus right here? +5, right? +5 is the maximum oxidation state of phosphorus. Yes? This is the maximum oxidation state of phosphorus. Phosphorus cannot increase its oxidation state beyond +5. So phosphorus over here cannot undergo oxidation. Right? So this compound cannot be acting as a reducing agent. It cannot act as a reducing agent. This H3PO4, it cannot act as a reducing agent because reducing agent is the one which reduces others, itself undergoes oxidation. Right? Oxidation means increase in oxygen state. But phosphorus is already in its maximum oxygen state. It cannot increase its oxygen state beyond +5. Yeah? Right? So what is going to be the final answer then? It's going to be H3PO4 only. Yeah? Simple? Absolutely, guys. Wonderful. So the question was asked in your mains 2019 from the same chapter. Okay, an example of a disproportionation reaction. The question was asked in JEE Mains 2019 March attempt. You can kill this one as well. Well, if I look at all the reactions, I need to see which one is the disproportionation reaction, right? Well, people, if you look at the last reaction, copper over here is present in +1 oxygen state. Copper right here is present in +2 oxygen state, right? Copper right here, its oxygen state is 0, right? +1 to +2 increase in the oxygen state. +1 to 0 decrease in the oxygen state. Oxidation state of same element is increasing as well as decreasing simultaneously. So I'll say the CuBr undergoes disproportionation. So it is the example of disproportionation reaction. As simple as that, right? Yes? Right? Whereas in hydrogen peroxide, the oxidation state of oxygen is going to be -1. Yeah? So so option 4 is going to be the correct answer of this question. Well, you can check the others as well. You won't be finding any other disproportionation reaction apart from this option 4. Yes? Well, the question was asked in your JEE Mains 2019, right? JEE Mains 2019. In order to oxidize a mixture of 1 mole of each ferrous oxalate, ferric oxalate, ferrous sulfate and ferric sulfate in acidic medium, the number of moles of KMnO4 required is, first of all, in acidic medium, let me tell you, in acidic medium, the N factor of ferrous oxalate is going to be 3. N factor of ferric oxalate, we have discussed all these N factors in detail if you remember. N factor of ferric oxalate, it is 6. N factor of ferrous sulfate is going to be 1. N factor of ferric sulfate, it's going to be, just a second. See guys, understand one important thing. Iron over here is in +3 oxygen state, right? Sulfur over here is in +6 oxygen state, right? KMnO4, we know KMnO4 converts Fe di positive into Fe tri positive, right? It converts Fe di positive into Fe tri positive. But right here, iron is already in +3 oxygen state. Yes? So KMnO4 is not going to react with this one. Okay? KMnO4 is going to convert this Fe di positive into Fe tri positive. At the same time, it converts oxalate into carbon dioxide, right? Over here, iron is already in +3 oxygen state. So KMnO4 has nothing to do with Fe tri positive, right? It will convert oxalate into what? Into carbon dioxide. Similarly, over here, there is Fe di positive. It will convert Fe di positive into Fe tri positive. So this KMnO4, it is only going to react with this one, and this one, right? It is not going to react with this one, right? Now, what is the concept which I'll be using over here? In order to oxidize a mixture of 1 mole of each, right? So I've got a mixture containing this, and this, right? And in this mixture, I'm adding KMnO4. But I got to know KMnO4 is only going to react with this one, and this one, right? Okay. I can write something like this. Number of gram equivalents of KMnO4 reacted. I'll say first of all, some part of KMnO4 is going to be reacting with this one, and some part of KMnO4 reacting with this one, some part of KMnO4 reacting with this one. I'll say number of gram equivalents of KMnO4 reacted should be equal. Number of gram equivalents of ferrous oxalate, right? FeC2O4, which would have reacted in this reaction, plus number of gram equivalents of what? Number of gram equivalents of ferric oxalate, Fe2C2O4 whole thrice, plus number of gram equivalents of what? Number of gram equivalents of FeSO4, right? Now, number of gram equivalents of KMnO4 will be equal to number of moles of KMnO4 multiplied by, what is the N factor of KMnO4 in acidic medium? That's 5, is equal. Number of gram equivalents of ferrous oxalate. Number of moles of ferrous oxalate, that's 1, multiplied by N factor of ferrous oxalate, that is 3. Yes, plus number of gram equivalents of ferric oxalate. Number of moles of ferric oxalate multiplied by N factor of ferric oxalate, plus number of gram equivalents of ferrous sulfate. Number of moles of ferrous sulfate multiplied with N factor, that is 1, right? So from here, you get the value of N as, it's going to be 3 plus 6, 9, 9 plus 1, 10, 10 divided by 5 comes out to be 2. So N value will come out to be 2. So number of moles of KMnO4 which are required to react with 1 mole, of each of these species in the mixture in acidic medium is going to be 2. So 2 is going to be the final answer of the question. I'm sure it's clear to everyone, right? You can let me know in the chats if it is clear so that I can move on to one more. The question was asked in your JEE Mains 2019. Right, guys? And the ones who have not liked the video, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Okay, perfect, guys. Let's move on then to one more question. Okay, the question was asked in your JEE 2019 mains, right? JEE Mains 2019. Similar type of question. Have a look. 50 ml of 0.5 molar oxalic acid, oxalic acid, right, is needed to neutralize 25 ml of sodium hydroxide solution, all right? The amount of NaOH in 50 ml of given sodium hydroxide solution is, all right. See guys, oxalic acid, it's reacting with sodium hydroxide. Let me tell you the N factor of oxalic acid is 2, N factor of sodium hydroxide is 1, right? Let me equate their milliequivalents first of all. I'll say milliequivalents of oxalic acid is going to be equal to volume of oxalic acid multiplied with normality of oxalic acid. Well, volume of oxalic acid is 50 ml. Normality of oxalic acid is going to be molarity multiplied by N factor, 0.5 multiplied by 2 comes out to be 1. These are the milliequivalents of oxalic acid, right? Similarly, milliequivalents of sodium hydroxide is going to be equal to normality of sodium hydroxide multiplied by volume of sodium hydroxide. So normality of sodium hydroxide I got to know equal to 2. This is the normality of sodium hydroxide solution, right? Now, as for the question, the amount of NaOH in 50 ml of the given sodium hydroxide solution is, first of all, normality of sodium hydroxide is 2. Since N factor of sodium hydroxide is 2, so molarity of sodium hydroxide is also 2, right? Well, molarity of sodium hydroxide solution, it's going to be equal to mass of sodium hydroxide multiplied by 1000 divided by molar mass of sodium hydroxide multiplied by volume of solution in milliliters, right? This value is equal to 2, right? Mass of sodium hydroxide I need to calculate. A molar mass of sodium hydroxide, that you all must be knowing, 40 grams per mole. Volume of the solution which I'm using right now, that is 50 ml. This value is 50, correct? So from here you can calculate mass of sodium hydroxide solution. Yes. So mass of sodium hydroxide solution will come out to be 2 multiplied by 40 multiplied by 50 divided by 1000, and finally you'll be getting the mass of sodium hydroxide exactly coming out to be 4 grams, right? That's something which I was supposed to calculate. I'm sure it's clear to everyone again. Yeah? Right? Exactly, it's 4 grams. Absolutely, guys. Let's move on to one more then. Okay, the question was asked in your JEE Mains 2019 from the same chapter. The question says 25 ml of given HCl solution requires 30 ml of 0.1 molar sodium carbonate solution. What volume of this HCl solution is required to titrate 30 ml of 0.2 molar NaOH aqueous solution? First of all, let me tell you, HCl solution, HCl's N factor is 1, right? Sodium carbonate, its N factor is 2. HCl, its N factor is 1, right? NaOH, its N factor is going to be 1, correct? Now guys, have a look exactly. Sivari, I've started chemical bonding on NEET Elite channel today only, right? You can check this session. Basically, I have started chemical bonding on NEET Elite channel, and on this channel from tomorrow I'll be starting chemical equilibrium, so that 2 chapters will go parallelly on both the channels, right? Okay. Akash, actually I was not well, so yesterday I did not take any of the session. All right, have a look exactly how to solve this question, guys. First of all, HCl solution is reacting with sodium carbonate solution, right? Let's try to equate their milliequivalents. Milliequivalents of HCl is going to be normality of HCl multiplied by volume of HCl. Yes. Milliequivalents of sodium carbonate. Normality of sodium carbonate, which is going to be molarity multiplied by N factor. So 0.1 multiplied by 2 comes out to be 0.2 multiplied with its volume in ml, that is 30 ml. So from here, you get the normality of HCl solution, which comes out to be, this is 6, right? It's going to be 6 divided by 25. This is the normality of HCl solution. The volume of this HCl solution, required to titrate 30 ml of 0.3 molar, 0.2 molar aqueous NaOH solution. So I need to calculate volume of this HCl solution, right? So now let's try to equate milliequivalence of HCl with the milliequivalence of aqueous NaOH. Milliequivalence of HCl is going to be normality of HCl multiplied by volume of HCl in ml is equal to milliequivalence of aqueous NaOH. Normality of aqueous NaOH, molarity multiplied by n factor, that is going to be 0.2 only, multiplied with its volume, that is 30. So from here you can get the value of V1, right? This value will come out to be 6, right? 6 multiplied by 25 divided by 6, the value comes out to be 25 ml, right? So 25 ml is basically the volume of HCl solution which is required to titrate 30 ml of 0.2 molar aqueous NaOH solution. So option 2 is going to be the correct answer of this question, right? Isn't it simple, guys, again, right? Yes? Simple. First, equate the milliequivalence of HCl with sodium carbonate, then equate the milliequivalence of HCl with sodium hydroxide. Get the answer. That's all. Yeah? Absolutely, guys. Absolutely. Let's directly jump into one more question then. Okay. In the reaction of oxalate with permanganate in acidic medium, the number of electrons involved in producing one molecule of carbon dioxide. Okay. See, guys, the question was asked in your JEE Mains 2019. Let's see exactly how this question is solved. It's a very simple one. First of all, your oxalate ion, C2O4 di-negative, right? With permanganate ion, right? MnO4 negative. In acidic medium, remember in acidic medium, MnO4 negative converts oxalate into carbon dioxide and itself gets converted into Mn di positive. Yes? The number of electrons involved in producing one molecule of carbon dioxide. In order to produce one molecule of carbon dioxide, how many electrons are involved, right? So first of all, I'll try to balance the reaction. Let me tell you, this oxalate ion, it has got the N factor of 2. This has got the N factor of 5 in acidic medium, so this should be 5 times, this should be 2 times, right? You know how to balance the redox reactions in acidic medium through ion electron method, through oxidation number method. Just crisscross the N factors first. Now, we have got 10 carbons on this side, 10 carbons on this side, 2 manganese, right? Balance the oxygens. This should be 8 times water molecules and this should be 16 times H positive. This reaction we have already balanced a few minutes back only, right? Now we will have a look. Exactly have a look. Oxidation state of carbon right here is +3 and right here it's +4. So +3 to +4, what is the change? 1 is the change in the oxidation state for 1 atom of carbon, but I have 2, right? So 2 is the change in the oxidation state for 2 atoms of carbon. So N factor of this oxalate ion is 2, right? So +3 to +4, it is undergoing oxidation. Oxidation means loss of electrons. Yes? So I can say 1 molecule of oxalate ion is losing 2 electrons. So 5 molecules are going to lose 10 electrons. Yes? 5 molecules of oxalate are going to lose 10 electrons, correct? Okay. So for the formation of 10 molecules of carbon dioxide, how many electrons are being exchanged? 10 electrons are being exchanged. So for the formation of 1 molecule of carbon dioxide, how many electrons are being exchanged? 1 electron will be exchanged. So 1 is going to be answer of this question, right? 1 is going to be answer of this question. As simple as that, right? Right, people? Yeah? For the formation of 10 molecules of carbon dioxide, 10 electrons are exchanged. So for the formation of 1 molecule of carbon dioxide, simple, 1 electron will be exchanged, right? Vijit, I've already discussed redox titrations. Okay, let's move on to a few more questions then. AIEEE 2007. Consider a titration of potassium dichromate with acidified Mohr salt, right? So I'm making potassium dichromate to react with Mohr salt using diphenylamine as indicator, the number of moles of Mohr salt required per mole of dichromate ion, right? Remember, guys, one thing. In Mohr salt, in presence of dichromate, right? In presence of dichromate, in Mohr salt, only Fe di positive gets converted into Fe tri positive. So what is the N factor of Mohr salt? Have a look. +2 to +3. Change is 1. So 1 is the N factor of Mohr salt. That's all. Remember, 1 is the N factor of Mohr salt. Correct? And dichromate ion, Cr2O7 di negative in acidic medium, right? Its oxidation state, its N factor is going to be 6, right? Now, guys, just equate the gram equivalence of dichromate and Mohr salt, right? I'll say number of gram equivalence of dichromate ion Cr2O7 di-negative should be equal number of gram equivalents of what? Number of gram equivalents of more salt. Yes? Okay. Number of gram equivalents of Cr2O7 di-negative is equal number of moles of Cr2O7 di-negative per mole of this, that means 1, multiplied by n factor of Cr2O7 di-negative 6. Number of gram equivalents of more salt, number of moles of more salt multiplied by n factor of more salt, that is 1. So n value will come out to be 6, right? So n value comes out to be 6. 6 is going to be answer of this question, right? So what is 6 basically? 6 are the moles of more salt which are required per mole of dichromate ion. And if you want to know the formula of more salt, this is the formula of more salt, wherein iron is in +2 oxygen state and in presence of chromate, right? This Fe di positive gets converted into Fe tri positive. That's all. Yeah? Right? I'm sure it's clear to everyone. People, one more question which was asked in JEE 2001 from the same chapter, and I'm sure you can easily solve this one. In the standardization of Na2S2O3 using K2Cr2O7 by iodometry, the equivalent mass of K2Cr2O7. Well, people, you know K2Cr2O7, it gets converted into Cr tri positive. K2Cr2O7 gets converted into Cr tri positive. That's something which we have discussed in detail, right? It gets converted into Cr tri positive. So first of all, +6 to +3. What is the change in oxidation state? 3. 3 is the change in the oxidation state for 1 atom of chromium, but out 2, right? So its n factor is 6. What is the n factor of K2Cr2O7 then? Molecular weight of K2Cr2O7 divided by 6, right? Option 2 is going to be correct answer of this one. I'm sure it's clear to everyone, right? Let me know fast in the chats. Absolutely, guys. Yeah? Okay, so this is a reaction which takes place here, right? Okay, your Cr2O7 di-negative gets converted into Cr tri positive, yeah? All right, JEE 2001. This reaction is the example of what? This reaction is the example of what? Let's check it out. Let's calculate the oxidation state of chlorine. It's going to be X, right? It's going to be X. Oxygen shows -2 oxygen state is equal to -1. So X value is going to be +1, right? So +1 is the oxidation state of chlorine right here. What about the oxidation state of chlorine right here? It's going to be +5 and oxidation state of chlorine right here is -1. +1 to +5 increase in the oxygen state. +1 to -1 decrease in the oxygen state. So oxidation state of same element is increasing as well as decreasing simultaneously. I'll say this species undergoes disproportionation, right? So option C is going to be the correct answer of this one. As simple as that, right? JEE 2001 question this was. Yeah? Okay. Moving on to one more. JEE 2001. An aqueous solution of oxalic acid dihydrate. Oxalic acid dihydrate is made up to 250 ml, right? The volume of 0.1 normal NaOH required to completely neutralize 10 ml of this solution. First of all, let me calculate the molarity of this oxalic acid dihydrate solution. What is the formula of oxalic acid dihydrate? H2C2O4.2 times H2O. This is the formula for oxalic acid dihydrate first of all, right? Let me calculate its molarity. Its molarity is going to be equal mass of this substance multiplied by 1000 divided by molar mass of this substance, which is 126 I assume, right? Volume of this solution is 250, correct? This is 1, this is 4, this is 1, this is 2, so this is 2. So molarity of oxalic acid solution is equal to 2. Molarity of oxalic acid solution is equal to 2, right? And remember, n factor of oxalic acid solution is also 2. N factor of oxalic acid is also 2. N factor of oxalic acid is also 2. Its molarity is 2, its n factor is 2, right? The volume of 0.1 normal NaOH, aqueous NaOH solution to completely neutralize 10 ml of this oxalic acid solution. Let's try to equate their milliequivalents. The volume of 0.1 normal NaOH aqueous solution, okay? So let's equate the milliequivalence of NaOH solution with the milliequivalence of oxalic acid solution. Milliequivalence of NaOH solution is going to be equal to normality of NaOH multiplied with its volume, which I need to calculate in milliliters, is equal to normality of oxalic acid is going to be equal to molarity of oxalic acid multiplied by 2. So 4 multiplied by volume of oxalic acid solution I'm using as 10. So volume of NaOH I got to know 4 multiplied by 10 is 40 divided by 0.1, right? I think we did some mistake. Did I do any mistake anywhere? In the calculation process we did something, right? Okay, so it is not 2, it is 0.2, I think, right? Because I cancelled 63 with 126 as 1 by 2. Yeah? Right? Do you remember? We cancelled it there. Let me once again calculate the molarity of oxalic acid solution. Molarity of oxalic acid solution is going to be equal to mass of oxalic acid multiplied by 1000 divided by molar mass of oxalic acid, which is 126, multiplied by volume of solution in ml, which was 250. Right? So this is 1, this is 4. Absolutely, yes, we are right only. So this is 6.3 multiplied by 4 divided by 126, right? This is 1, right? This is 20, correct? So this is 1 by 5 basically. 1 by 5 means 0.2. So it's not 2, basically it is 0.2. So 0.2 multiplied by 2 is 0.4. So right here it is 0.4. It is 0.4. 0.4 multiplied by 10 comes out to be 4, right? 4 divided by 0.1 comes out to be 40. So 40 ml is basically the volume of NaOH which is being used in this reaction, right? Okay. Yes, tomorrow we are going to start chemical equilibrium, absolutely. So option 1 is going to be correct answer of this one. Okay, the oxidation number of sulfur in these compounds. Right here sulfur does not have any charge. Over here sulfur is going to have +1 oxygen state. Right here sulfur is going to have -2 oxygen state. Simple rules which we have seen for the calculation of oxygen state, right? So 0 + 1 - 2, 0 + 1 - 2, 0 + 1 - 2. Option A is the one which is correct among all, right? Yes. Amrut, let me tell you, the session which I took on NEET Lead channel today, right? It is basically the quick revision of periodic classification only, right? The first session of chemical bonding, that was the quick revision of periodic classification. You check it out. All right, 1997 AIEEE question. The number of moles of KMnO4, that are needed to react completely with 1 mole of ferrous oxalate. Let's call this as number 1. Let's call this as number 2. KMnO4's N factor of KMnO4 in acidic medium is 5. N factor of ferrous oxalate, right? N factor of ferrous oxalate is going to be 3. That's something which we have discussed. Number of gram equivalents of KMnO4 should be equal to number of gram equivalents of ferrous oxalate. Number of gram equivalents of KMnO4 is equal to number of moles of KMnO4 multiplied by N factor of KMnO4. Number of moles of ferrous oxalate multiplied by N factor of ferrous oxalate, right? N1 value, the number of moles of KMnO4 I need to calculate. N factor of KMnO4 acidic medium is 5. N2 value, number of moles of ferrous oxalate is equal to 1. N factor of ferrous oxalate is 3. So N1 value will come out to be 3 by 5. So 3 by 5 moles of KMnO4 are required to react completely with 1 mole of ferrous oxalate. So 3 by 5 is going to be answer of this question. Simple, correct? Yes? Right? Okay. One more question was asked in AIEEE 1999. The moles of KMnO4 that will be needed to react with 1 mole of sulfite. 1 mole of sulfite. Let me tell you, KMnO4 in acidic medium, it converts sulfite into sulfate, right? We have discussed that too. Sulfite into sulfate. And this is the reaction first of all. Let me show it to you. Your KMnO4 or MnO4 negative, it converts sulfite into sulfate and itself gets converted to Mn dipositive. Due to which N factor of this MnO4 negative comes out to be 5. And what is the N factor of this sulfite? See, over here, the oxidation state of sulfur is +4. Right here, the oxidation state of sulfur is +6. So +4 to +6, what is the change? 2, right? So 2 is the N factor of the sulfite, right? Okay. Now, gram equivalence of MnO4 negative should be equal to gram equivalence of this. Gram equivalence of MnO4 negative is equal to moles of MnO4 negative multiplied with N factor is equal to gram equivalence of sulfite. That's going to be equal to moles of sulfite, which is 1 multiplied with N factor, that is 2. So N1 value comes out to be 2 by 5. So 2 by 5 moles of MnO4 negative are required to react completely with 1 mole of your SO3 dinegative, right? Or since it is a balanced chemical equation, you can simply see 2 moles react with 5 moles, so 1 mole reacts with 5 by 2 moles, right? Or 5 moles react with 2 moles, 1 mole reacts with 2 by 5 moles, right? Yes? Right, guys? Let's see, do we have more questions or not? Yes, we have got one more question. 1988, wow. Can you solve this one, guys? Can you let me know its answer? I'm looking at your chats only. Can you let me know its answer? Yes, Shaurya, it's complete. The equivalent mass of MnSO4 is half of its molecular weight when it converts into. All right. See guys, the oxidation state of manganese over here is +2, right? Oxidation state of Mn over here is 2x minus 6, so it is +3. Oxidation state over here is +4. Oxidation state over here is +7. Oxidation state over here is +6, right? Yes. So the equivalent mass of MnSO4, MnSO4 is going to be molar mass of MnSO4 divided by n factor of it. So when can be its equivalent mass? Half of its molecular mass. So when can be its equivalent mass? Half of its molecular mass, right? Equivalent mass will be only equal to half of its molecular mass when n factor of this substance is 2. When can be its n factor 2? When Mn plus 2 gets converted into Mn plus 4, such that change in the oxidation state becomes 2, right? So such that its n factor becomes 2, right? So MnO2 is going to be answer of this question, right? Simple. Yes. Let's see if we have more questions. No guys, this was the last question of the tonight's session. I'm sure you would have enjoyed the session, and with this your whole redox reactions would have got completed, and the ones who have not joined into the batch, right, which started on the actual Vedantu platform, right, I would suggest you guys to go through the details, right? Do get enrolled into that batch which is there on the actual Vedantu platform. Apart from these YouTube sessions, it's going to be highly beneficial for you, trust me on that, right? And if you're new to Vedantu, you have no idea how the Vedantu platform looks like, you can take these subscriptions for a month at least, right? Take these subscriptions for a month, see if they are working for you. If you think you are getting benefited, then go for the actual 2-year classroom program, right? Okay. Yes. So if you are going for light, this is the course fee for complete 2 years. Yeah, this is the course fee for complete 2 years. No need to pay this much of amount in one go. You can pay this much of amount in installments as well. And people, at the same time, you can take this plan for a month as well. Just 1,500 you have to pay for a month, correct? Right? Give it a try for a month. Join the batch for a month. See you if you are getting benefited, and I'm giving you guarantee you will be getting benefited. You are going to love it, and eventually you'll enroll yourself in the 2-year classroom program, right? Okay. Any of the subscriptions you can take. What is the difference? Where the difference lies? The difference lies in this. In your classic, you get doubt solving on mobile app. You'll be given an app in which whenever you find any sort of difficulty, you will have to put your doubt in that app and you'll be getting the answer itself. And why is its course fees high? Because you get personalized mentor in all the 3 subjects, right? Yes, top 7, it's good, right? So people do get enrolled in this one, and there's a link in the description box of the video. You need to click on that link, which is there in the description box. Use the coupon code WBPRO, then only you'll be getting some additional 10 to 20% off, right? There is one more link, that is about the Telegram. Do click on the link, get added to the Telegram group, and the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. So people, tomorrow we are going to start chemical equilibrium. Do not miss that session at all, right? Let's meet up tomorrow at the same time, 10:30. Till then, you take care. Bye-bye. God bless you all. Love you all. Take care. Yes, Raja Pratap, that will be done too.